This video will be going over Chapter 12, Section 4, Three-Dimensional Figures. So one new word that you're going to learn in this lesson is called a plane. And what a plane is a two-dimensional flat surface that extends in all directions. And below in this little chart are different ways that planes may be related in space. So it has two dimensions, right? Length and width. And they can intersect in a line. They can intersect at a point there at A, or they could not cross at all. So they're parallel planes. Because remember, parallel lines, they have so much in common. It's a shame they'll never meet, so they're never going to intersect. Here we have the word solids, which is intersecting planes, form these three-dimensional figures. So, for example, down here in this cube, you have a plane here on the top, that I just moved, on the bottom, and along all the sides. So each side of this cube is a plane itself. A polyhedron is a three-dimensional figure with faces that are polygons. So every side of a polyhedron is a polygon. So it can't have curves, right? It can't be an open gap. As long as all the sides are polygons, it's a polyhedron. Now we've got pyramids versus prisms and cones versus cylinders. So pyramids and prisms have one main difference. A prism has two bases. So a bottom base and a top base. A pyramid only has one base, and then they all come together to form a point at the top. So prisms have two bases, pyramids only have one. And same for cylinders. Cylinders, they have two bases there, one at the bottom, one at the top. Cones only have one at the bottom, and it comes together at a point on the top. So think of a prism, you just stretch it straight up. A pyramid, you pull them together and make a tip. So this wants us to identify our figure, name the bases, faces, edges, and vertices, which I skipped part, so we're going to go back here. And we're going to label things. So this here is an edge. All of the long pieces that are at kind of like at a corner, but not really, are the edge. So it's where one face turns into another one. And your face is like that entire side. So on a cube, there are 6 faces. Think each place where like a number would be on a die is a face. Your edge is where the faces meet, or is where two faces meet. And a vertex is like the corner where multiple faces meet. A diagonal, I'll label it for you in here, is where it goes from one corner to another. So like there to there, right? We're going from one vertex to another vertex. That's your diagonal. So where it cuts through the center of that shape from one vertex to another one. Okay, so back to where we started. The way you label a shape, or to identify it, I guess, is you first figure out what the base is. So the base of this shape is a pentagon. So it's a pentagonal. And then we go, okay, is it stretching up and have two bases, or coming together at a point? It's coming together at a point, so it is a pyramid. Our base is, once again, just the pentagon. Its faces, I'm going to count the faces. So it has our bottom face down here. It has this side, so 3, 4, 5, and 6. So there are 6 bases, or faces. All of the sides leading up to the top of the pyramid, as well as our base. Our edges we need to count. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges. Our vertices, so that's all our little corner pieces. We have 1, 2, 3, 4, 5, 6. I'm just going to label that vert. We have 6 vertices. And our skew lines. And what a skew line is lines that do not intersect and do not lie on the same plane. So they're not on the same plane and they don't intersect. Sorry, that took a while there. So an example of a skew line would be like here, AB, and then also CD. Those lines are never going to intersect, and they don't lie on the same plane. So that's an example of a set of skew lines. Here we're adding in a cross section, and what a cross section is when a plane intersects or slices a three-dimensional figure. The intersection where it cuts through is called the cross section. So you're imagining cutting the shape with your plane. So if I were to cut a vertical slice through this cone and open it up, the cross section is what that looks like. So if I were to cut a cone in half and open it up, the cross section would look like a triangle. If I cut it at an angle, it would be a parabola, which looks something like this. And if I cut it in a horizontal slice, it would look just like a circle. So there's your circle on here, it would look like a triangle. So it makes your different shapes. So we here have a fluorite crystal. We want to draw what the top view would look like and a side view. So our top view, if I were to look at that from above, it would look something like this, right? Because it's coming together at a point, but if I'm just looking from the top, it's a square. My side view would look something like a triangle with a flat section, and then another triangle at the bottom. It wants us to describe a shape resulting from a vertical cross-section of this figure. So if I were to cut it in half, it would look pretty much the same as our side view. So you could say the vertical cross-section will look similar to the side view. And that's what I got for you for Chapter 12, Lesson 4.